Okay, in lesson 6, we are going to start something called proportion, and that's really the big vocabulary of today. If you look at your vocabulary, they're going to talk about an if-then statement. They're just talking about if something is relating. So if you have a ratio that is going to be equal to another ratio, that together makes a proportion. So anytime you have two equal ratios that are equal, you have a proportion. For example, if I have 1/2, 1 to 2, and if that would equal 4 to 8. So you can see the top to bottom is getting twice as big, and the top to bottom here is also getting twice as big. So this is a proportion. We can check them to see are they equal by a lot of the same methods we've done before. And we could find a unit rate. We could multiply the numbers diagonally. Basically, if these two ratios are equal, they are a proportion. So that's what the if-then statement is. So we're going to be talking a lot about if this happens, then this will happen. If you can go 54 minutes in 6 miles, if it takes 54 minutes to go 6 miles, then how long would it take to go 2 miles? So you're just seeing a relationship that way. So that's what the if-then statement's talking about, and that's what proportions are. So if those two are equal, they are a proportion. Just to review really quickly, a rate, you know you're dealing with a rate if they have different units. So anytime you have different units comparing like minutes to miles, those two are different units, that's a rate. Ratio is obviously just a comparison of two quantities. A unit rate, I really hope you remember that from the last lesson. It's when it compares something to the number 1. Anytime you have a number compared to 1, you're talking about the unit rate. All right, let's go ahead to the next page. Okay, this is a review question from last week. It says, it's recommended that when cooking a turkey, you allowed 40 minutes for every 2 pounds of turkey. Marjorie cooked her 8-pound turkey for 220 minutes. Is this the correct number of minutes based on the recommendation? Explain your reasoning. There's lots of ways to do this. Some kids will find the unit rate and then make the prediction. Some kids will just use the information they have. Like, for example, 40 minutes. We're supposed to take 40 minutes for 2 pounds. So they immediately write that down. And then they go over and they went, well, for 120 minutes, you cooked an 8-pound turkey. So then they just looked on, is this right? And so many kids will say, well, are these equal to each other? Well, if you look at the bottom, you're getting 4 times bigger. The top better get 4 times bigger. And you can see that 40 times 4 is not 120, so therefore no. So we put a big line through that equal sign. These are not equal. I would definitely not eat that turkey. Then the next question, Pascal cooked his 9-pound turkey for 180 minutes. Is this the correct number of minutes based on the recommendation? We could do exactly what we did before. We could take the 40 for 2 pounds and then compare that to the 180 and 9. Or we could look at a unit rate if we wanted to. If we did a unit rate, if it's 40 minutes for 2 pounds, unit rate is just changing this bottom number to a 1, and that's very simply done by just taking the top dividing by the bottom. So 40 divided by 2 is 20. So basically we know we should cook 20 minutes per pound, okay? And you have 9 pounds, so every pound takes 20 minutes. If you have 9 pounds, that better get 9 times bigger. So 9 times 20 is 180. So yes, you go ahead and eat that turkey. Okay, now we're going to start solving the proportion type questions. We're going to be looking for the if-then statements. I just want to caution you, you're not always going to see the word if and then in your question, especially on this example. So if you look at example 3, it says, last weekend Will helped his father plant a garden. For every 3 tomato plants, they planted 2 basil plants. If they planted 6 tomato plants, how many basil plants did they plant? So you can kind of see the if. They're asking if something happened, then what else is going to happen. So right away, when you look at that, we should find the relationship. So right here is a sentence that we would want to underline. For every 3 tomato plants, they planted 2 basil. So the graphic organizer looks a little different when we do the proportions, but it works basically the same. So this is the top part that says if. All right, and if you look at the question, it says, hey, for every 3 tomatoes, so we put 3 tomato there, they get 2 basil. So we fill it in very, very similar to what we were just doing last few lessons. Over here is the then part, though. So now, if we know this is happening, 3 tomato to 2 basil, we should remember from the way we did it before, these labels got to match, tomato, tomato, basil, basil, because remember, these are proportions, so these are equal to each other. So the question we don't know is how many basil, so that's going to be where my X goes. I don't know that number. And the only other number they're saying, well, what if they planted 6 tomatoes? So 6 is going to go right there. All right, to solve this, you can multiply across and divide all ways, or you can look at the top as getting twice as big, so the bottom is getting twice as big. So the answer is going to be a 4. But over on the next part, it says 4 other people in Will Street were also planting gardens. Alyssa next door planted 4 tomato and 1 basil. Jack planted 1 tomato, 5 basil. Rico planted 9 tomato, 6 basil. And Kelly planted 5 tomato, 2 basil, who had the same ratio of tomato plants to basil as Will. So we remember Will's ratio tomato to basil is 3 tomato, 2 basil. So we've got to find which one is the same as 3 to 2. And it's tomato, basil. So we're going to always talk about the tomato on top. When you look at Alyssa, she plants 4 tomato, 1 basil. So 4 to 1. 4 to 1 and 3 to 2 are not equal ratios because they're reduced and they are not equal to the same. So we can get rid of 4 to 1. Jack, 1 to 5, 1 to 5. These two are not going to be equal either because both of them are reduced and they aren't equal to each other, so that's not it. Rico planted 9 to 6, so if I write 9 to 6, are these two ratios equal? You can see the bottom's getting 3 times bigger and the top's getting 3 times bigger. That means they are truly equal. And finally, Kelly is 5 to 2. Well, 3 to 2 and 5 to 2 can't match. They're not going to be the same number. So basically, we know it is Rico. Okay, in the next example, it says Toshi used exactly 2 cans of icing to cover 24 cupcakes. How many cupcakes can she, oops, that was cut off, ice with 3 cans of icing? So you can see a relationship that you're going to underline up here. She used 2 cans to cover 24 cupcakes. So that goes in our if spot. So you can say if she used 2 cans and covered 24 cupcakes, so we're finding that relationship. What we don't, and the label's got to match, so I know this has to be cans and this has to be cupcakes. We don't know how many cupcakes, that's where my X is. The question's saying you use 3 cans of icing, so the 3 is going to go up here. Okay, remember these are still a proportion. These are equal to each other. So this is hard. You cannot tell how many times bigger the top is getting. So we can't use that method anymore. Now, one method you could always use is multiply the diagonal numbers, multiply these 2, and then divide by the 2. We could always do that, but we need a calculator for that. One more method you can use. If you can look at the relationship top to the bottom, do you see how this is getting 12 times bigger? If 2 is getting 12 times bigger, then this better get 12 times bigger. So 3 times 12 is 24. So she's going to be able to make, 3 times 12 is 36. So she's going to be able to make 36 cupcakes. The next question, it says the following tuna casserole recipe serves 16 people. It says if Dora needs to make the casserole for 40 people at her party next weekend, how many cans of tuna does she need? So we're asked how many cans, so we want to look at the recipe. The recipe calls for 2 cans of tuna. And the other thing we need to know in the recipe is how many people that would serve. That would serve 16 servings. So there's our information that we need in the if part. So if you need 2 cans of tuna to serve 16 servings, so now that I have the if part down, the rest is really easy because these labels have to match, cans, servings. We are asked for how many cans, that's where my X goes. The question's saying you want to serve 40 people. Well, that's going to go on the bottom. You can see when we want to solve these, we want to see if they're equal. Multiplying on the bottom doesn't work real well. I don't know how many times bigger you're getting on the bottom, but we could look at this. This is getting 8 times bigger. So in other words, the bottom to the top, we're dividing by 8. So if we just did the same thing here and divided by 8, so that would be a 5, because 5 times 8 is 40. So our answer is you need 5 cans of tuna. Okay, the challenge problem says, bodybuilders say that while lifting weights, they need to drink an amount of water proportionate to the amount of time they lift. The standard amount is 8 ounces of water for every 30 minutes of weightlifting. If you plan on lifting weights for 2.25 hours, how many ounces of water should you drink? So we're going to go to the question and we're going to look for that relationship. So the relationship they're giving us is they're saying this is what you should have, 8 ounces for every 30 minutes. So that's going to go in the if blank. So if you drink 8 ounces, you should drink 8 ounces in 30 minutes of lifting weights. So now, if these are proportion, we know our labels are going to match. So we're going to go ounces and minutes. And then we are going to put the X what we don't know. We don't know how many ounces of water, so that's where your X is. And the only problem with this one, next one is, if you go ahead and put this 2.25 here, that's not right, because it doesn't say 2.25 minutes, it says 2.25 hours. So basically, we've got to change that to minutes. So 2 hours, hopefully you agree, is 120 minutes, because it's 60 minutes for each hour. So 60 and 60 is 120. When you look at a 0.25, the 0.25 part, that fraction is a quarter. So you can see that kind of looks like a quarter is money. It is 1/4. And if you took a clock and you cut it into quarters, 1/4 is this far, which is 15 minutes. So basically, the 0.25 part is 15 minutes. Add that on to the 120, you get 135 minutes. Okay, now we need to solve. Except, we cannot tell what's happening on the bottom, so that doesn't help us. I also can't tell what's happening from 8 to 30. So now I'm required to figure out, to get that missing number, I can always multiply across. So if you take a calculator and type in 135 times 8, type those in, and then divide by 30, you'll get your answer. And the answer is 36. Okay, on this last one, it says Raphael finished the Minneapolis Marathon, which is 26.2 miles in 4.75 hours. At this pace, how long would it take him to run the 50-mile JFK Ultramarathon in Washington, D.C.? So this is the information they give us. They're saying this is how far he runs. He goes 26.2 miles, and he does that in 4.75 hours. Okay, so if you ran that far, we can then predict how far he'd run another marathon. So we're just going to go ahead and copy their labels. This is miles, this is hours. The question is how long. That can be where our X is. We don't know the hours. But 50 miles would go right up top here. Okay, so these are not easy mental math numbers, so I'm going to grab my calculator. I'm going to multiply the numbers that are diagonal from each other. So I'm going to take 50 times 4.75, and then I'm going to divide by the other number, which is 26.2. And the answer, I get 9 point, it's really, really long, so I'm going to round to the thousandth, 9.065. It was a 6.4, but the next number was an 8. So that's how many hours it would take him to run. So 9 hours of running would be pretty long.